All right, my friends, let's take a look. Since law of sines wasn't going to work out, let's see what happens when we apply the law of cosines. So you could solve for, any of the side lengths. So let's say, any of the angles. Let's say I'm going to aim for solving for angle C. I'm going to go ahead and start then with 3.5 squared. This is not the only way to do this problem. You could have started with 7.9 squared or 5.1 squared. I'm just going to show this version of the story, okay? So 3.5 squared would equal 7.9 squared plus 5.1 squared. So, looks kind of like Pythagorean theorem, right? And then now let's subtract that error off. So minus 2 times 7.9 times 5.1, and then times the cosine of, since I started out with 3.5, I would be solving for this angle over here, which I called angle C. You may have called it something else. I don't know. Okay, so I decided to use this viewer to demonstrate, because I want to make sure that I demonstrate a couple of things on the calculator that you may or may not already know about. Okay, now we want our final answer to be accurate to the thousandths place, so there's some things you can do with your calculator to avoid these little round off errors. Okay, so first I'm going to isolate the cosine of angle C. And so I would take 3.5 squared, and then I'm going to subtract off 7.9 squared, and I'm going to subtract off 5.1 squared. Okay, and then I'm going to divide that result by the quantity negative 2 times 7.9 times 5.1. There we go. You also could have done some algebra solving on the paper to get to here, but you can see I've got cosine of C approximately equal to 0.945. Now, I want to make sure that I use this number with the extra decimal goodness, so my next answer is as accurate as possible. So the next thing I'm going to do is take arc cosine of both sides to get C isolated. And then I would find out, make sure, by the way, your calculator is in degrees mode. And then we'll just do arc cosine. And then one thing I want to make sure everybody knows to do is if you want that decimal but you don't have to retype it in, then use second and then this button down here for answer. And it'll just insert that answer with all the detail. Okay, so it looks like I'm getting that angle C is approximately 19.043 degrees. And that's one of my answers, 1 down, 2 to go. And so I'm doing good. Okay, now, it turns out I'm actually going to need this measurement later. So I would like to have all the decimal goodness past the thousandths place that I wrote down on my paper. And so I'm going to make sure that everyone in my class has the option of using the store as feature. So if you push store as, it'll take the last number you had on your calculator, and then you use the alpha key, and you can assign A, B, C, D, right? Any letter in the alphabet, you can see these little green letters. You can assign any letter to of the alphabet to be this value. And for me on my paper, I called it C, so I'm going to go ahead and say, hey, I want C to be this number. So from here on out, if I use the letter C, my calculator knows that I want it to be that number. So it's kind of nice, Hey, and if you use so many letters that you run out, right? If you get past Z, you could always do store as AA, right? So you have lots of things you could store if you ever wanted to. Okay, now with that said, now let's talk about, once you know angle C, what's a quick way to get one of the other angle measures? You could use law of cosines again, but it's a little more time consuming than other things. So I'm going to switch to law of sines because I now have a complete ratio. I have angle C and I have side length C there. So I'm going to switch to law of sines. So sine of C, which is approximately 19.043 degrees, divided by side length C, which is 3.5, would be, I'm just using approximately equal to because that is not, exact. That's a rounded answer. And then now let's talk about what should I go for next, angle B or angle A, and does it even matter? And it does matter, because if I try to go for angle B next, do you see how angle B is opposite the biggest side length? That means it's likely to be an obtuse angle. And arc sine, which I would need, cannot go past 90 degrees. And so I could actually get pretty misled if I try to go for angle B next. So for that reason, my friends, I'm going to strategically go for angle A next, since it is not going to be obtuse. Okay, again, because I'm gonna have to use arcsine, and arcsine can't go past 90, it would make sense to not go for the angle that's opposite the biggest side length here. Okay, all right. There we go. Okay, now I'm just going to solve for angle A. So some cross products, I'd get sine of A would be approximately 5.1 times sine of 19.043 degrees all over 3.5. And then I'm going to take arcsine of both sides to get A by itself. Make sure when you write arcsine that you write it on the left side of what you're taking the arcsine of. Since arcsine is a function, right? Like we never write x of f, we always write f of x, right? So always put functions on the left. Does it really matter? Yes, it does. All right, here we go. So I still have this 19 something something sitting on my calculator, so I'm just going to take the sine of that, sine of answer, and then multiply that by 5.1, divide it by 3.5, and then I'm going to take the arcsine of that results. There we go. And I got approximately 28.388 degrees. Okay, so I have angle C and angle A, and now I just need angle B. And so what's the path of least resistance for finding angle B? Yep, good old-fashioned geometry. All three angles should add up to 180 degrees, so I'm just going to subtract these two numbers away from 180. So I'm going to do 180, take away answer, to make sure I have all the decimal goodness there, and then I can do minus and then C, since I stored the other angle as C a while ago, and then I could find that that angle B is indeed obtuse. There we go, and I solved for all the information that I needed from the triangle, and I'm done.